Welcome to the Met-Averse podcast, episode 2. My name is Noah Kravitz. Coming up on the show, a conversation with Jacob Steeves and Shaabana from Bittensor. Bittensor is creating an open, decentralized peer-to-peer network that functions as a market system for the development of artificial intelligence. That's a mouthful, but they're all really meaningful words. There's a lot packed in there. Jake and Ala do a great job of explaining what they're doing, why they're doing it, what it's all about, all the technical details. But in essence, what they're doing is they're building an online community, a network for engineers, people creating machine intelligence, artificial intelligence, to come together for a few purposes. One is to increase the efficiencies in the way that AI is created these days. Jake and Ala identified a problem with just inefficiencies in the way that artificial intelligence is created, the way that advances are shared and built upon by the community. They think they have a better solution in Bittensor, so we get into that. And then the other thing is something that gets into the concept of a DAO, DAO, or decentralized autonomous organization. This essentially is a structure for building a community online that has ownership and governance baked right into the structure. So you can use a DAO theoretically to build anything from a social club to a company with a sort of alternative form of governance to actually, in theory, a government itself. There's a whole lot in all of that. Jake and Ala, again, we have a great conversation about it. So stick around, even if you're not interested in machine intelligence and this idea of building a better artificial intelligence marketplace. These core concepts of building a decentralized organization on the blockchain are really interesting and really vital to why people are excited about all this stuff. So stick around. Also, there's a great article in the New York Times from March 8th. I'll put a link in the show notes so you can check it out. But the article is called Reality Intrudes on a Utopian Crypto Vision. And it gets into this whole idea of DAOs, what they're being used for, for good purposes and for scams for nefarious purposes. So check that out as well. Another thing about Bittensor, what I really like about what this group is doing is that they're also really interested in AI itself and what it is now and eventually might be used for, and trying to find a way to keep that aligned with human interest, the greater good, and the well-being of people first and foremost. So great conversation. Stick around for that. First, a couple of quick notes of housekeeping. Episode 1 of Met-Averse is live. It's a conversation with Nanea Reeves from Trip about the mindful metaverse. Check that out if you haven't already. Nanea is a great guest. It's a great conversation. I'm thrilled that turned out to be the first episode. So take a listen, watch on YouTube if you like. It's good stuff. Also, I mentioned YouTube. You can get the podcast audio only wherever you get your podcasts, Apple Podcasts, Spotify, wherever else. So subscribe, share it with your friends. If you like it, leave a review. Also, the podcast is available in video format on YouTube, so check that out. And then also, there's a Substack, Met-Averse.substack.com. There's a newsletter, blog post, newsletter kind of thing. We're going to be posting once a week for now, so you can get a little more in depth. If you prefer to read, then listen, or if you want to do both and just get a little more depth and a whole bunch of links to go learn more on your own, sign up for the Substack. Again, the first post rather is up, second post coming this week. Right now, we're aiming for a Tuesday podcast, Wednesday newsletter update schedule. So that may get refined as we go, but that's what we're on right now. Podcasts on Tuesdays, newsletter updates on Wednesdays. So Substack will get you all of that, or just subscribe to the podcast wherever you like. And we're on social media, of course, who's not, on Twitter and on Instagram right now at Met-Averse Pod, all one word. And finally, if you want to leave a comment, if you have a question, a suggestion, just want to say hi, you can do so on the socials, or if you're old school and you like email, you can email us, metaversepod@gmail.com. Meta, M-E-T-A, averse, A-V-E-R-S-E, pod, P-O-D, @gmail.com. All right. I think that's it. Let's get to it. Jake and Ala from Bittensor, enjoy the episode. All right, today we are talking to the guys from Bittensor. I'm here with Jacob Steeves, Jake, and Ala Shaabana, the co-founders of Bittensor. Gentlemen, thank you so much for coming on the show and welcome.
Thank you.
Thanks for having us.
So, all right, who wants to go first and tell us? There's a lot to get into, obviously, and we were talking before I hit record about how the different areas of all of this stuff, Met-Averse, Web3, blockchain, everything that, we're trying to explore in the show, and how the work you're doing kind of fits all of the buckets and then some. So why don't we start by just giving us an overview of what Bittensor is and what you guys are working on?
Sure, no problem. So we hit a lot of buckets, right? So AI and blockchain. How does that make any sense, right? The ideas for Bittensor came around in 2015 by just noticing the computational scale of the Bitcoin network, right? It's the largest supercomputer in the world. It's like 500 times larger than all of Google's data centers combined,
right?
Hashing out, and many times larger than that now.
Right. And for the uninitiated, I know there'll be at least a few folks listening who are like, wait, what is all this? There's a bigger computer. This is spread out. These are nodes spread out.
Yeah, they're spread out. They're working on a common problem, though, right? You could say that it's a supercomputer working on hashing the next block of the Bitcoin blockchain.
Right.
And, it raises this question like why and how?
Those are the two big questions.
Yeah, like how does this massive network, come into be when there's nobody running it really? It's decentralized and stuff like that. And, we think the fundamental reason is that Bitcoin, along with inventing this digital trust with digital currencies, allowed for the first creation of these digital markets, right? Where you can build like this commodity market, global commodity market for the creation of hashes. And that's stimulated the advancements in chips, ASIC chips for hashing the Bitcoin blockchain next hashes. And also stimulate this hive mind, this global hive mind of engineers that are putting on their desktop computers. And obviously it's evolved to be really sophisticated. Now you have these massive data centers in China and Kazakhstan and across the United States where you rows upon rows of ant miners, hashing out. And at the time, both me and Ala were machine learning engineers. And AI is also fundamentally a computational problem. It's the intersection between algorithm, compute, and data,
right?
And it's building this thing. You could call it a commodity in digital intelligence. And so we were like, well, why don't we apply this new technique, this new invention of digital trust and digital currencies to create this commodity, which is incredibly valuable, right? It's valued in the billions of dollars by companies like Google and OpenAI. And so we, around that time, we started working on building a mechanism. What does that mechanism look like? How could we possibly measure machine intelligence and then get computers from all across the globe to build it and contribute it to this network? And so that's what Bittensor is. Basically, it's just a protocol for measuring and incentivizing the production of machine intelligence. Decentralization is part of it, right? So AI is part of it. Blockchain is part of it. But you would say that we're not trying to create the same killer app as Bitcoin. Bitcoin wants to be decentralized because they want to be censorship resistant. We're taking advantage of decentralization because we have engineers around the world and connecting them together. We're taking advantage of decentralization also potentially because we want to approach this alignment problem in AI. You may have heard this, right? How can we align the development of artificial intelligence with humanity? And we think decentralization, which is about power and control, is also an answer to that. That's a really high level, explanation of where Bittensor is and like what we're about.
Right. So there's a lot in there to unpack that I think is important. I was going to say, I don't want to put you on the spot and ask you to explain the blockchain, except I think I'm going to wind up doing that with every guest, at least for the first, however long of the show. So
sure.
a couple of things in here. You guys are Bittensor. I'm saying guys because you're two guys, but I don't mean to be gender specific. Bittensor is building out a network.
Yeah.
Is that fair? Is that a fair? Okay. And the idea is to bring people together, bring folks together who are working on artificial intelligence. So machine learning engineers, let's say, there are other job titles too, from across the globe, working on their own, computers, workstations, wherever they are, right? To share intelligence, to share sort of the output of their own work, to maybe work collaboratively on larger problems, that kind of thing?
Exactly.
Okay.
Yeah.
So I guess before getting into some of the stuff like, what's hashing and decentralization, all that, maybe just to keep it in the realm of software engineering and that kind of thing, how does this differ from open source? How does it differ from other ways that people have been and are collaborating, working remotely, whatever it is?
Right. I think
so.
Sorry, go ahead, Alan.
No, I was just going to basically, I wanted to say, bring it back down to a lower level. Essentially, as it stands today, as Jake was essentially saying, is that the field of AI is problematic, right? So first of all, AI production itself is inefficient. There's thousands of engineering terms worldwide. There's all kinds of websites like Kaggle and so on that really enable you to create these models and kind of try to either monetize them in some way or have them kind of published and have people use them. But what you're really doing is you're just building on the existing research, but your actual model that you're building is actually probably learning stuff that other models have already learned. Right. So there's a bit of an inefficiency there, right? Kind of retraining all over again every single time. And this is because we don't have the ability to measure intelligence as a commodity today.
And can I ask you real quick, just to break down that process of training a model, feeding it with data, that kind of thing? Can you maybe on a very high level just kind of explain for folks not in the field sort of what that entails?
Yeah. So I think on the most basic level, you essentially have three working groups when you're training a model. You have your data set, which could be anything. So let's say, for the sake of example, you are trying to train a model that learns what buses look like on pictures. And then you have your model.
You read my mind. I was like, captures.
Captures, yeah. So then you have your model, which is essentially just it's effectively a computer program that will optimize its own internal coefficients to understand what information is coming out of the data set that will help it identify what a bus looks like, for example, like it has wheels and so on. Right. And finally, you have your loss function, right? All of the loss function is, it sounds like a scary term, but what it really is just an indicator for the model of what kind of mistakes it made, right? Okay. How incorrect was it by the time that it learned whatever a bus should look like, right? And that's essentially really the most basic form of machine learning. You just have your data, it could be labeled or unlabeled. And if it is labeled, then you want to basically just check how close you are to the right ground truth of the data. So then,
if I'm working by myself and I have trained a model and I'm happy with how well it's able to identify bus versus not bus, how would somebody like, say yourself, use my work?
Right. So let's say, for example, I'm trying to train a model that is working on something similar. Let's say I'm trying to identify what cars look like, not buses, right? So one of the most infamous problems of machine learning is something called catastrophic forgetting, right? Where, for example, if you flip a single pixel on an image, it's going to think it's a giraffe, not even a bus anymore.
Right.
So one of the things that for example, I could do if I'm training this model to learn what cars look like is I can maybe speak to yours and say, hey, I'm looking at this kind of picture. What is yours learning? What kind of insight can you give me from that? And what's going to happen is yours is going to give me back some information and it's going to say, okay, maybe it's this and this. And this is what I think it looks like. And that's kind of what I can learn from you and to kind of make myself a little bit better. Yep. Now, the difference is, obviously, it's kind of maybe a little bit down the line, but some models might not be compatible, right? Maybe what information you give me is going to make my model a little bit dumber, maybe not smarter.
Right.
So in this case, what I would do is maybe I would look for someone else to speak to and learn from them. And that's where kind of the concept of the network that Jake was describing comes in.
Yep. Perfect. That was great. Okay. Sorry to interrupt, but that was good ground setting. So.
Yeah, absolutely.
Yeah. So like if you look at a lot of these other projects they're sharing models, like Hugging Face is a really good example, right? You're sharing the weights of a trained model. But you're not actually sharing the knowledge itself. So when you check out a Hugging Face model, you look at its performance on a data set. You say, okay, how well did it do on glue, for instance, which is a benchmark, like it's a test that you can put your models through, right? And so we're measuring and searching the space of machine knowledge using human defined explanations of its intelligence, right? But the beauty of digital currencies and using computers to measure something like a commodity is that it's high resolution. So we can actually measure how valuable this model, the information that this model is producing, using entropic methods like Fisher's information, which is like a measure of the informational significance of the model to another. And before we couldn't do that. We couldn't really measure the performance, the value of one computer to another, because we didn't have the technology to do that, right? Bitcoin, that was the invention of Bitcoin, right? Digital trust, the ability for computers to have a conception of trust and value that they can transfer between each other.
And so how is Bittensor taking advantage of that?
So we built this network where it's like Bitcoin. I mean, so your listeners might not know too much about the way that Bitcoin works, but essentially Bitcoin is a set of computers that are validating the work done by the other computers in the system. Proof of work. You've heard that before, right? So we, Bittensor is a proof of work network also, where the computers are validating whether or not the other computers in the system are producing information that is valuable to the collective.
Okay, right.
So they're producing some numbers that we call them tensors, the things that are being passed between the computers. Tensors being the root word of languages like TensorFlow, for instance, which you may have heard of that language.
Yep.
Having done many podcasts on NVIDIA. So they're passing tensors, and these validators are validating whether or not that information is valuable. And so, fundamentally, that's all that Bittensor is. It's a mechanism for computers to reach consensus about which computers are producing information that's valuable, and then paying them out accordingly.
Got it. And so, to ask a very sort of genuine but also naive sounding question, what is happening in the network that couldn't be done? Is it just a matter of the network can do it so much faster than humans could validate? Or is there, something happening that, and you were talking to, let me rephrase that. Or is there something happening that's just beyond the sphere of what even that most highly trained human could do?
Well, I think so, because, as I mentioned at the beginning of the podcast, right, this amazing quality of the Bitcoin network that you have people across the globe, fighting tooth and nail to build computers that are faster, and finding energy sources which are free and available to mine this cryptocurrency.
Right.
And so we have this exact same like competitive system where, hey, like I'm an engineer in India and I couldn't get into Google because I didn't go to the right school, but I'm actually really, really, really good machine learning engineer. And so I can come into Bittensor and I can find, there's some cheap computing in my dad's laptop, but whatever. And I can build a special neural network that adds just this niche thing to this global market, right? And so we're leveraging the power of markets to make the system of machine intelligence, of artificial intelligence, much more efficient. Right. And I don't think there's any company in the world that it can claim to be not just their own compute, but the stitching together of everybody else's compute at the same time. Right. That's going to let us to scale.
Just to add to what Jake was saying as well, as he kind of mentioned the word market, right? So a lot of these other applications that have kind of tried to do something similar, what's happened is there's always a human bias in there, right? Even in academic research, there's human bias. We're more likely to pick research done by the most famous researcher as opposed to something done by someone maybe from a different corner of the world that might not be as famous, but still just as valid, right? Sure. So what we've done with Bittensor is effectively it's a few lines of code that'll enable whatever model that you have currently, doesn't even have to be a new model, to learn for itself and to choose for itself whom to reward and whom to learn from. So we're removing this aspect of human bias and we're actually letting the models themselves choose who's useful for business. There must be some human bias initially with the design of the network or the design of the model at first. Does that get filtered out over time to the point where, for all intents and purposes, the models really are choosing the best other models? The design of the network itself is really defined by the problem they're trying to solve. Okay. Right. So if you're trying to solve a very specific problem, you're going to have a very specific architecture to it. So that's kind of the only bias you're going to have is towards the problem you're solving, but not towards other models. And then over time, really, it's going to be, as you said, it's not really going to be that relevant anymore.
It sounds to me, and if I'm way off, tell me, but it sounds to me almost like the Silicon Valley ideal of meritocracy, just, hard coded and writ large and unleashed on the whole internet.
Yeah,
exactly.
Basically, we're in this kind of long tradition in artificial intelligence. I think you can situate us inside, which is, as the clockmakers of these incredible complex systems, we are backing away from how much control we put into them. So I'll give you an example. Like in the early days of machine intelligence, they tried to actually encode a specific quality into the visual language model, right? Okay, it detect edges and then detect cylinders, right?
Right.
But as the field has progressed, the methods that have been the most successful were the ones that have just stepped back and let computational adaptive system find the solution. And so we're kind of going, hey, let's step back and instead of defining these problems really explicit, let's build markets which are like meta systems and let the network evolve itself towards the solution, through that adaptive ability.
Right. So let's talk about the market, the word market. What's the incentive? How does it actually work? If I'm, if we finish talking and I hop on my my imaginary machine with my imaginary models that I'm not smart enough to build, right? I put them into I join Bittensor. I help work on a problem. I'm identified as providing some valuable intelligence. Then what happens?
So the question is how do we determine if it's valuable?
Or how am I rewarded?
How are you rewarded?
Yeah. How does the market aspect of it work? Yeah.
Right, exactly. So we have a form of consensus. So we have a set of validators on the network. It's proof of stake, essentially. To your listeners, proof of stake just means your weight in validating others, like how many votes you have, is a function of how many tokens you have attached to your computer.
Okay. And I not to derail you, but I get tokens by doing good work.
Exactly.
Okay.
Exactly. Yeah, that's what I was just going to go to. So it's okay. So they validate the knowledge that your computer is producing. So Ala mentioned this thing called catastrophic forgetting, which is this issue where your neural network, trained on one problem, when you try to train on another problem, you forget the previous one. Right. And the solution to that is actually to look at the weights of your neural network and go, hey, this one's super important for this previous problem. Let's saturate it. And so there's this way, a statistical technique really, of determining whether or not a particular component of a neural network, these massive multi-hyperparameter functions that we train in neural networks, in machine intelligence, how valuable that thing is, right? And so these validators are doing the exact same thing. They're going, hey, how valuable is this parameter? In this case, it's a computer producing tensors,
right?
And goes, okay, well, it's worth 5. Not 5, but it's all normalized and statistical. Say 5 out of 10, and then we tally that up, and that becomes a scoring, a global scoring, which then advises the inflation of the digital currency. So it's very similar to say Bitcoin, where the incentive is based on inflation. Okay, and so Bittensor has its own token. That's right, Bittensor Tau. Tau, right? Okay, and what is for you guys are rolling with me, so I'll just ask them in sort of plain speak. What is Tau worth? Let's say I get 5 Tau. What can I do with 5 Tau? Al, do you want to answer that?
So we're kind of delving into legal territory here. We actually can't divulge the actual.
If you want to read a safe harbor statement, go for it.
We can't delve into those specifics, but effectively, the only thing we can tell you is that the Tau itself is not being sold on exchange or anything like that right now. It's not. We kind of adopted a fair market launch, so there is no ICO, no pre-mine. Every Tau in existence today has been fairly mined and has actually contributed to the knowledge of neural networks in the past.
But Al, I might mention that so the real value of Tau is based on the value of the network that we're creating, right?
Correct.
And so because Tau is the key that you use to get access to the system. And so it's like a utility token, right?
Right.
It's killer app is the intelligence that's produced by the network. It's unlike again, to use Bitcoin as an example.
No, sure.
So kind of went to full legal mode there. My bad.
No, I think it's also needed.
Well, on a sort of very abstract level, this notion of decentralized everything, right? And this notion of rebuilding, that as I'm learning more about all of this stuff, which is really I'm just scratching the surface. But this notion of decentralized currency and this notion of sort of democratizing access to different things, and in this case, I'm a highly skilled machine learning engineer who knows how to do stuff, but for whatever reasons doesn't have a job that either, allows me access to work on certain kinds of problems or to work with certain kinds of colleagues or to get compensated at, the market rate of a Google engineer in Silicon Valley for that matter, right? I guess I'm kind of wondering the idea of, you are making it easier for folks to contribute to and collaborate on this intelligence that could theoretically, benefit the whole world, right? The flip side is sort of, I still have to eat and food costs money. So is that, and it might be a thing that over time I learned to decouple in my head, right? But I'm thinking of, I've earned a token. The token gives me more weight in the community. That's worth something. I get it. But sort of from at the other end, like if my contributions to machine intelligence are ultimately going to be used by some company who's making a ton of money, how does that happen? Or not how does that happen, but sort of like what's in it for me, right?
Right. So you got the Tau by contributing intelligence. Right?
Yes.
They need the Tau to access it.
Got it.
So
okay.
They're your customer.
Got it. Okay. So then, can I sell them the Tau? Can I trade them the Tau for, I don't know, Dogecoin or, whatever that I could potentially convert into food?
That is the eventual idea. Yeah. Is that you'll be able to kind of sell in your Tau after you've earned yourself.
And I'm not trying to get at your secret sauce or, hold any feet to the fire. I'm just trying to understand on a sort of more global level. I had a conversation yesterday with, somebody working in the VR XR space, but we got to talking about tokens, and I lost my train of thought. I apologize. And talking about the idea with NFTs, for instance, that a musician could record something, or an artist is a better example, right? And the whole idea of the reselling of art is a huge global marketplace. Under fiat currency systems, the original artist doesn't necessarily see a cut of sales when the third owner sells to the fourth owner. One of the things about NFTs is the idea of changing that by baking that, royalty, so to speak, baking it in. So is there a similar function if we're looking at the use of tokens to make markets in,
Yeah. So in modern AI discourse, a lot of the conversation has been around access, open access, open AI.
Right.
But we think that the bigger issue is ownership, AI ownership, who actually controls the AI, who gets to say what it's trained on, that kind of thing.
Right.
And with the way that we've tokenized Bittensor, as an engineer, you by holding Tau, you also own the network, right? So that's ownership of the system, not just the ability to access it, which is also very important, right? It's also an open network, but the ability to access it and own it. So, but if you did sell your Tau, all of it, then you'd lose your tokenized ownership. And maybe we could build something in it where you get some sort of echo of your previous ownership, but that would be essentially like just selling a few tokens less. You know what I mean?
Right. Yeah. Yep. What led you to go after, make this your mission and go after building it this way?
Yeah, we both have our own approach to this. I'll let Al tell his story. But we met up, so we both have our own reasons.
Yeah, let's get the origin story.
Yeah. Sounds good. Actually, it's a great idea. So both Jake and I kind of are ex-Silicon Valley folks. I worked at VMware for quite a bit. Jacob worked at Google for quite a bit. At least I'll tell on my side. I worked on decentralized AI for quite a while, especially in VMware systems, where it's basically hyper-converged infrastructure. We have many computers kind of trying to speak to each other and kind of learn from each other in a certain sense. Ended up kind of working a little bit of research and development on that. And in that time, I kind of arrived at a similar conclusion to Jacob. That was before we met. And we ended up with, actually, sort of after we met, we ended up with a similar kind of outlook onto AI, which is basically the three problems that we described: inefficiency, centralized ownership, and effectively just the idea that general intelligence is not really attainable by a single person. We ended up meeting in a research collaboration that was kind of online. It was called 4AI, and I had presented something that was akin to what Bittensor was doing. And cool. Jacob kind of ended up reaching out and saying, "Hey, I'm like 3 years ahead of you doing this. You should just join me and we'll work on this." Right. So we kind of ended up working together since.
That's really, really well said, Alex. I forget the concept, but it's like this idea that ideas are in the noosphere and you just kind of like pick them up. So like there's people that have them at the same time. Right. And so that was very much what happened with me and Ala. So like, but I kind of have my story was before I was at Google, I was working for DARPA, building what are called neuromorphic chips. You probably heard that term. Super cool company.
I've heard it and I nod along to it, and I'm not really 100% sure what it means.
Yeah, basically the idea. I mean, you could have a podcast just on this concept.
Right, I'm sure.
Really, really cool. But neuromorphic basically just means like the brain. You know. Right. So chips that are like the brain. Mm-hmm. And I was working for this company that was building synapses, like out of these things called memristors, which were like resistors, but you could change the resistance.
Okay. Right.
Really cool idea. And so they're like apps. So you could put them on a chip. You could build a brain's a bunch of synapses, and you could train it a billion times faster than NVIDIA can. Worth an episode of your podcast, definitely. But the problem with this, and I was working for this absolute genius. His name was Alex Nugent, absolute genius. But the problem was kind of like, there's no direct market for me to plug this super fast chip into. Right. I'm this genius. I got this great idea, but I have to go and work for IBM. I have to go work for NVIDIA for my idea to actually, gain from its, ability to beat this market. Right. And so that was, that's one of the explanations for how I came to Bittensor, was like, thinking of that, what if my boss could plug his awesome, super genius chip into a market that actually could reward and incentivize the production of these things. Right. He'd be able to build his company a lot faster.
And so how's Bittensor structured as I guess it's a project that is under the umbrella of OpenTensor. Is that right?
Yeah. So the OpenTensor Foundation maintains the project. Bittensor itself is fully open source, blockchain and AI. And we kind of have a Discord community that's full access, and there's, I believe, correct me if I'm wrong, Jake, we have about 10 developers at this point, including you and me. And
we're pretty small,
very small, very scrappy team. And we launched the network out in November last year, November 3rd, and we've been maintaining it since.
Right, we're taping beginning of March, so about 4 months. And how many? Is it miners the right term? How many participants, folks on the network?
We have a. Oh, go for it, Jake.
Yeah, I was just gonna say miners. Yeah, exactly. So we measure the number of active computers, which is like the computers that are responding.
Okay.
And that's just over, what was it, $1,500?
Yeah, we just passed 1,500 last week.
Nice, congrats. And so I have to ask. You mentioned a little bit about the difference between a proof of stake network and a proof of work. A lot's been made about the environmental impact of these, giant crypto mining data centers, if you will, crypto farms, mining farms. All the electricity is being used, where the electricity comes from. Obviously, there's too many things wrong with the world to list right now. But global warming, climate change, all of that is near the top of the list.
Right.
What's your, I guess, first of all, what the Bittensor, do I call it the Bittensor blockchain? What's the right way to speak?
Sure. You could call it the Bittensor blockchain. Right?
Okay.
Yeah.
So what's the environmental impact right now, so far as you know? And then what's kind of your take, both in terms of what your company's do or your project's doing, but more globally about,
UW.
blockchain becoming green enough that it's, you get where I'm going.
Yeah, no, I get it. And the argument against the proof of work blockchains, I think a lot of the time it stems from a misunderstanding of the fact that the POW is actually doing something productive. Oh, it's just doing something stupid. It's just burning.
Right. There's all these computers trying to solve the same math problem nobody needs the answer to. And
no one needs the answer to. So what's the value? And then,
right.
And so you could, and I think that obviously the value is the fact that it secures the Bitcoin network. But if you don't value Bitcoin, then it doesn't seem very valuable, right? right. But we're in a luckier position because we're actually producing something that people automatically understand the value of that thing. You're producing artificial intelligence. It's a commodity. It's valuable. People want it, right? So it's very easy for us to go, well, look, no, actually, this is something that people want. It's not wasted compute cycles.
Yeah.
I mean, on top of it, the artificial intelligence system is very inefficient. As Ala was mentioning at the beginning of the call, like there's a lot of repeat work going on. The next best model in the world, GPT-N, had to relearn everything that GPT-3 learned. Right. And so if we can move into a world where machine intelligence, there's protocols for sharing machine intelligence that are really sophisticated, and the corpus of global AI is something that people can build off in the same way that a human doesn't just learn everything, and I don't have to reinvent mathematics every time I come, I'm born, right? So if we think that we're actually solving efficiencies in the traditional sense of AI, so we're making it more green. But to be honest, we can't make that claim. All we can say is point to it and go, look, let's try to fix this aspect.
Right. Real quick, proof of stake versus proof of work in 30 seconds.
Sure. In proof of work, you're measuring votes in a consensus mechanism. You're reaching consensus about who thinks of what, and so you need to vote. In a proof of work, you're voting based on computational power, usually a proof of work algorithm like SHA-256, which is just producing hashes. And in a proof of stake algorithm, the number of votes is based on a tokenization of those votes. So, the number of tokens you have. And so that ties the finite element to tokens rather than proof of work, which is computation. And they have their ups and downs. They have their various pros and cons.
Sure. So as I'm thinking about the closing minutes of our conversation here, I've got kind of two threads, but also want to open it up to stuff that you guys might want to talk about that we haven't hit upon yet. So how do you want to do this? Are there things on your cliff notes, so to speak, that you wanted to hit, things you want that Bittensor's doing that you want to talk about? And if you want to back burner that, I'll hit you with one of my two questions.
Ala, what do you think?
It's a very good question. So the one thing that we wanted to kind of maybe emphasize a little bit, I'm not sure if that's really worth digging into, it's that everybody at the project, including myself and Jacob, are all AI engineers. So our main kind of focus has been mostly on the AI bits to kind of make sure everything's validated properly, everything is working properly. And one of the milestones that we are trying to hit is eventually to beat the size of GPT-3. So at the moment now, we've reached, Jake, I believe it was 225 billion parameters.
That's a low estimate.
Yeah. So for context,
and again, I'm sorry to interrupt you mid-thought, but for folks who don't know what GPT-3 is, we've thrown it around a couple of times.
Yeah, absolutely. So GPT-3 is kind of OpenAI's flagship language model at this point. So it's kind of state of the art. It's the latest and greatest, and that's what we're using. And so GPT-3's parameter count is 175 billion. So we're kind of approaching that number rapidly. And cool. The next thing they want to do at Bittensor eventually is kind of beat that benchmark and kind of beat that state of the art.
Right. Cool.
And so that's kind of what most of our efforts have been at, and that's what they're going to continue to be at this year.
And so along those lines, and this is one of my two questions, is Bittensor the project? Are you growing in terms of staff numbers, or is the focus on, we've got what we need and really the power is in the network and it's all about, recruiting more folks to come on and take ownership and contribute?
We are doing both, actually. So
okay,
we are
cool.
growing in terms of staff numbers. We are actually actively hiring.
You can plug the job openings.
Absolutely. Yeah, please, by all means, reach out. We are wrapping up our Series A as well. And we're looking to kind of expand the team out quite a bit, maybe 30 people by the end of the year.
Nice.
And hiring all kinds of folks.
Cool. Okay, so here's what we'll land on. The singularity, sentient AI, where is this? Are we headed toward, is this inevitable, or the computer? I ask all the cliche questions, but you guys are in this, and you're in this also in a way that, I think anybody working in AI and machine learning is thinking about the future. It goes without saying, but there's something about your approach that's maybe even a step, sort of beyond. There's the race for the raw horsepower, to put it in probably not the right terms. But then there's also the thoughts about, well, how are we doing it? And how, as there's a community building aspect that is probably similar to corporations or companies in some ways, but obviously quite different. Either where do you see this headed? Or maybe a better question is kind of, what's your goal, or what's your kind of utopian end state for machine learning and AI and how it relates to human beings?
Right.
So can I lay the foundation down, Jake, and then you can kind of take off with it?
Yeah, sure.
So this actually tackles the third problem of our thesis, which is effectively that intelligence itself is not generalized. So the holy grail for any machine learning engineer is artificial general intelligence, AGI.
Right. Generally,
So the idea behind it is that what I think everyone is really kind of touching on lately is that it's not really attainable by a single team or a single company. There's just no way. It requires way too much manpower, ingenuity, compute, and time to actually reach. So, you've got companies like Facebook Meta, that are coming up with, 16,000 GPU powered supercomputers trying to achieve this, but really they're still dwarfed by things like the computing power of Bitcoin. So the only way that we can actually come close to achieving something like AGI or something resembling AGI is through all of us working together combined, right? Man didn't get on the moon through the combination of, a small team or like a small company. It was a combination of countless scientists and engineers working together.
It wasn't one guy in a cowboy hat with a rocket?
Absolutely, it was not.
Okay.
And so that's kind of that's kind of the third bit of our thesis that I wanted to kind of touch on. And then Jake, I'll leave the rest to you.
Yeah, exactly. So we're hoping to scale. We believe that the problem is actually a lot bigger than people claim, we're not
always is.
Yeah. There's actually this funny thing where it's like, people have thought that AGI was 15 years away since the 1950s. Like they always say it's 15 years away.
Yeah.
It's because you're dealing with something that's so unknown. So I guess that actually just tells you what the average, unknown amount of time is for people. So we don't really know if we're going to be able to create that, but we certainly think that like creating this community of machines or culture of machines, mediated by a market, global Bitcoin scale is how we're going to reach the level of compute that was required, and also the time scale. We're training like a single network over a very long period of time, and that's actually unique, So we're moving in that dimension. But the answer is we don't know if it's going to create AGI. But I think the important thing is like if we do create AGI, the question is who's going to own it.
Yeah,
and I think that's actually way more important than is it going to launch the nukes? I think it's whether or not AI is going to be controlled by a small group of people. Is it going to be centralized into the hands of those people? And I think that the solution to these problems is to work with tokenization to build technologies for ownership of AI where it's aligned with humanity, right? It's just our token or for our DAO is distributed into the hands of many people, and there's mechanisms in place to stop that thing from getting out of control and unaligned from humanity. And I think that's maybe the more interesting question and the much more difficult problem that we're working on. We don't have a solution. That's not our first technical challenge, but it's something that we want to draw people in. with potentially finding a solution to.
Excellent. I think that's the alignment problem, so to speak, is a great place to land here. Guys, for people listening or watching, we're video on YouTube, audio wherever you get your podcasts. There's my little plug. For folks who want to find out more about Bittensor, about OpenTensor, I know there's a white paper, a blog, job listings. Give us some URLs. Say them out loud. We'll put them in the show notes.
Yeah. So you can find us at bittensor.com. That's kind of the most straightforward way. There's our blog, our network visualizer, and everything is there. We also have a Discord channel, and we also have, I think it was a ghost blog setting. So honestly, you'll find all that information on the bittensor.com website. Please feel free to jump on there. And we also have a LinkedIn website as well.
Excellent. Well, Ala, Jake, thank you guys so much for taking the leap of faith to be one of the first guests on the show. But more importantly, for the conversation, there's a lot in there for folks to unpack. Maybe we can do it again, whether here or on the other channel, and dig in a little bit more to the stuff you guys are doing.
We'd love to. Thanks, Noah.
All right, that'll do it for this episode of Met-Averse. Again, thanks to Jake and Ala from Bittensor for a great conversation. Special thanks to Jacqueline from Bittensor for making the conversation possible. You can check them out on bittensor.com. We've got a lot in the works for you. There's so much to explore in the Met-Averse. We're just getting started. Did I say Met-Averse? In the Met-Averse on the Met-Averse podcast. We're just getting started. We've got episodes lined up covering everything, covering fashion and sneakers, covering cybersecurity and fraud, how to stay safe in the Met-Averse, covering the science behind emotions. How do you detect and process and deal with emotions when you're an avatar in the Met-Averse? There's so much to explore. I'm excited about it. Thanks for coming on the journey. Make sure to subscribe, leave a rating if you're so inclined, and hit us up. Say hi on the socials or via email, metaversepod@gmail.com. You can let us know what you think. You can suggest a topic or a guest, or you can just say hello. Whatever the case, we appreciate you. Thanks for listening. Again, my name is Noah Kravitz, and we'll see you next time on Met-Averse.